Hey there, everyone. Thanks for joining our webinar today titled From Digital Design to Asset Lifecycle Management, How Intelligent As-Builts Enable Smarter Workflows. I'm Nick Frank, producer at Trimble, and I'll be the moderator for today's webinar. Before I hand it off to our speakers, we do have a few housekeeping items to get to. Our webinar today should last about an hour. That does include the Q&A portion at the end. To make sure we keep the flow of the webinar, all attendees will be on mute for the duration of the presentation. You can submit questions at any time in the Q&A panel, and our presenters will get to as many as possible at the end. So please put them in the questions panel, not the chat. This webinar is being recorded. The video, along with all the slides, will be available in the next 3 to 5 days. We do have 2 polls throughout the webinar, so when they pop up, please take part in that. And stick around after the conclusion of the presentation for a post-webinar survey. We're always looking forward to your feedback and ways to improve. Now let's get to our speakers today. Adrian Patane has 20 years of industry experience working with Trimble's transportation and construction technologies on complex, wide-ranging, and environmentally sensitive projects across Australia, Europe, Asia, and the Americas. He now represents Trimble's federal and government infrastructure solutions for the Americas and has had a key role as part of Trimble's partner collaborations, working with DOTs and contractors around the country to help facilitate 3D construction workflows aided by various Trimble technologies. Maximilian Ovett is a solutions engineer who focuses on assisting customers envision solutions and workflows throughout the asset management lifecycle, so that they can effectively manage their assets and allocate resources. He previously worked for a forensic engineering firm providing services in the areas of accident investigation and reconstruction, vehicle crash analysis, failure analysis of engineering structures, and product safety evaluations. I mentioned that we do have some polls this morning, so here is our first one. What process would you most like to improve in your organization? Some of the answers: information workflow between your project stages, communication between your field and office staff, getting all your data in one place, efficiency with project budget. What are some things that you would most like to improve? I'll leave that open just for another 10, 20 seconds or so, and then we'll dive into the presentation. Awesome. Adrian, Max, we're getting some good information here. A lot of people want to get their data in one place. One of the big things that we are looking at. Give the poll another 5 seconds and then we'll close it out. Awesome. Thanks, everybody. Now, I will hand it off to our speakers, Max and Adrian. Gentlemen, take it away when you're ready.
Thanks, Nick. So really what we're going to cover today is really the fundamental tools and technologies that really can assist with getting to a digital as-built, and really sort of I would define as the what, the why, and kind of the how. So we're going to touch on a number of those different aspects, and really then talk about the benefits and how it all ties together with really some of the tools and technologies that really underpin these workflows, and really how we get to this, what we're defining as the intelligent digital as-built, which is something that's truly usable in your operations and maintenance phase side of things. And I guess the nice thing about having these workflows in play is that you do get to this as-built that's has construction intelligence built into it, has all of these other attributes that really make the operations and maintenance side of things quite the much more valuable as such. So I'm really going to be focusing on the kind of the key aspects from the design and construction side, and my illustrious colleague Max is going to cover off on the asset management side of things, and really talk about some of the specifics and really again how these two very important components tied together for a for that digital as built and the workflows that we're talking about. So here, if you've seen any sort of construction or digital construction and technology and innovation presentation, you've potentially seen some of these stats, and these are very legitimate stats. These are, percentages of challenges that that the industry is facing based on, innovation or lack of innovation in the construction industry as such. And really what we wanted to highlight, there's three, as you can see, there's three aspects of very much highlighted here. In other words, 30% of work of construction work is rework. 40% of projects are over budget, 90% of projects are late. And you combine that with the once in a generation funding that we're getting through the infrastructure bills, you've got a quite a mix of challenges and issues that we need to basically get around. And part of what the technologies and what we're talking about today are really aimed at highlighting how we can start to minimize some of these challenges, improve the adoption of technology, and really highlight how they can benefit these workflows as such. And so that's really, what I would hope would be some of the take-home points from this presentation, is to show you what we're doing, what Trimble has been doing for many years, building out an ecosystem to really get around and really transform these industries. Part of our ethos, or part of our approach, is to be transformational in the industry. And really, you can only do that when you've got the tools and technologies that really assist with that workflow.
And to echo Adrian on this, the tools, these percentages that we're showing on the screen translate over to the maintenance and the asset side, whereas projects over budget means we're having less budget to maintain. Projects late mean we don't have as much time to get our initial phases of maintenance done. And then construction rework is we're trying to understand where and what changed from our design and our as-builts.
So part of that really is, I was actually presenting last week at the ASCE CI Summit, and it was interesting. This kind of graphic came up in a couple of different presentations, and because it is very realistic, it is representative of what's happening at the moment. What it's showing is not only are we dealing with a fragmented sort of industry and siloed industry, but what we're dealing with is loss of attribution, loss of intelligence between each of these different phases. And the challenges there are, you're doing a lot of that rework, which means you're introducing potential errors. But to me, I guess the biggest point behind all of this is, instead of accumulating attribution and intelligence and data throughout the whole process, we're actually losing it and having to recreate it, losing it and then recreating it again. And again, that's just a fundamental, that's just reflective of what the industry's been doing in the past. And this is why we're highlighting tools and technologies that we're touching about today, because this is the end goal, is to get to a point where we don't have those drop-offs in data. What we end up with is a linear accumulation of data, where we're actually adding to, particularly if we're dealing with objects with properties as part of, representations of the true design data. What we're actually doing is adding intelligence to those objects, which means that by the time they do get to the operations and maintenance phase, they've got, not only do they have intelligence and attribution and metadata on those, and all of the accumulated data from the planning to design and build phase, then you're able to, they also have a history associated with them as well, which ties into the operations and maintenance side of things. So again, what we're really getting to is a point, or this is the end goal, is to get to this linear accumulation of data throughout the whole process, so that then when we do get to this digital as built, digital twin, digital representation, whatever you want to call it, it's something that is much more valuable than currently is the case.
And on the operation and maintenance side, we're having to do a very large portion of rebuilding and going through all of the paper records if they're paper, digital records if they're digital, to flesh out and build these operation manuals and our maintenance manuals and where our assets are located. Whereas in the design build phase, you don't have as much ramp up to do, but having that data flow seamlessly from planning to design to build into your operation and maintenance, and having that visibility through the process is really going to give everybody better access and information and ability to take action quickly and efficiently.
So part of the why that we want to talk about is really the, what's the value add? What's the value add for each of those different phases? And the nice thing is there is a significant value add for each different phase, but there's differences at those different phases too. In other words, at the planning and design phase, what we're seeing now is where designers are, able to provide designs that are closer to being constructible. Because historically, what happens is, again, the contractor may get a design, they don't understand, they don't trust the design that's come out of it, or more importantly, and that's just they have their own specialization. But what we want to do is, and that's kind of one of those silos, because again, if you're recreating data, then you're losing all of the, the effort that you did in the first place. So we want to make sure that the contractors are actually utilizing that data. And Trimble has been working with contractors for decades, using machine control, using that, creating that digital data, whether or not they got it in the first place. It may have come through on a PDF, but we're going away from that approach, and we're seeing the industry really starting to turn and see the value in that, because that is a significant drop-off in intelligence and utilization of data. So the contractors are obviously looking for better information, which means if they do, there's minimized rework. They're getting more intelligent information, which means that bids are more closer to reality. And then the nice thing is, of course, that flows on into the maintenance and operations side of things, because what we're seeing is deliverables for a digital as-built as part of that design process. Obviously, the best approach is going to be a model as a legal document throughout the whole design, getting to that end result of that digital as-built. But even if we understand that there's going to be different sort of entities that are working faster than others, and of course that may just be having a digital as-built. We're seeing that with some states as well. But the benefit, of course, is making sure that the infrastructure owners then do have a representation of the project that is up to date, that has been utilized in the construction phase, that has that construction intelligence built into it. And that's really the key aspect here. You may or may not have heard, in some of your conversations, especially at an owner level, it's like we do a project, it gets constructed, and we get nothing back. This is really what we're aiming to do, is to ensure that owner has that digital as-built as part of that deliverable, which means it's incorporating all of the positive aspects that we're going to be talking about as well throughout the rest of the presentation.
And the owner, as the owner, you'll be able to have visibility across the planning and design as well as the construction phase. And then once you receive that constructed model, you'll know all of the changes. You'll be able to see why something was done, why your maintenance might need to change to attribute to that fact, or adjust so you can better maintain the asset and move it forward. You can also do better visualization before people go out into the field, so you can have better planning, better traffic management. So by having these design and construction models to be able to visualize 3D and in the computer before you go out into the field is a big boon for your operators and your owners.
So far we've been talking about really the why, but now we're going to talk about the how. We're going to talk about some of the, the tools and technologies and reasonings as to why we're highlighting specific technologies. There's certainly many others that are associated with this approach, but what we're going to talk about is some of the key ones, or the key aspects, or key technologies and key workflows that really do result in this digital as-built and get through that process as such. So part of that is built around what Trimble's calling our digital or connected construction ecosystem. And what you're looking at here is the graphic here represents what we've been building out for many years. And again, historically, Trimble has been very heavy on the construction phase, survey, GPS, and we've expanded significantly from there to incorporate this entire ecosystem to really be able to ensure that we can break down those silos, get rid of those drop-offs in data that we're talking about. And you can only really do that when you've got a technology ecosystem like what we're looking at here, where you have data sitting in a centralized repository, sitting on an object-based model, and then being able to share conceptual and design data through to project management and scheduling, actually using that design in the execution phase, so the construction phase. Also being able to capture data from the construction phase and feed that into the process. We'll talk about that too. And then of course, getting to that end goal, that digital as-built, that digital twin for the operations and maintenance side. And like we've sort of touched on already, it's the beauty of having this connected workflow is where we're able to accumulate that data and metadata and feature attribution throughout the whole process. So when you do get to that maintenance and operations and maintenance side, you've got that information that you can utilize at that stage. So really inherently what we're doing is centralizing data between all stakeholders. We are bridging the gap between that design and construction, and then of course getting to that digital twin, that digital deliverable. And this is not just us, this is the whole entire industry. This is what Trimble is doing is reflective of the industry, but also transforming the industry by putting all of these pieces in play to enable these workflows. And of course, we're able to expand on those and then develop them as we learn through that process. And that's really the ongoing, but that's really where we see the industry going. And that's what our sort of approach here is with these tools and technologies as such.
And this is a great living document for the maintenance and the owners to use, as well as during construction and design, because it's changing. And then when it moves to maintenance, you guys are already able to track the changes. You're able to turn on and off layers and toggle features, so you can see what has changed, what is evolving, and then you can do that into the future from your maintenance aspect and capture that information and layer it on, so you can always track to see how your asset is evolving over time, what's changing, and then having that legal living history of where and what has been done previously.
So part of that is really built around what is that transformative technology that we're touching on. And one of the core underpinnings of that is really where that data sits. So in other words, it's pointless having the data and information there if you can't share, if you can't collaborate around it. And one of the things that we want to also do is go away from the file and folder-based approach that's done relatively fine in the past. But the problem is then, of course, where's that? Am I looking at the right file? Is the right version? Then when I'm importing into another software platform, am I losing attribution? Am I, is everything being dumped on a zero layer? Things like that really are what really do hinder the whole progress of sending that design from sending those designs from the design phase into the construction phase. And so part of that is building a multi-user common data environment, but we want to be able to collaborate and share around that. So one of the best aspects or the benefits of having that information sitting on an object-based database is that we're able to use APIs and connect that database to, of course, other Trimble software, but also other vendor or partner software, where they may be specialized tools that really you want to be able to still leverage those. You want to be able to make the most of those. That's really the value of having this connected collaborative approach here, is you're able to do that. And that really ties into the software agnostic approach. In other words, being able to use the best tool for that application also means we understand there's going to be other vendor software that you may want to utilize, or you've got experience and knowledge in that, and that's totally fine. That's what we want to do, and that's how we do see the transformation occurring here, because it's not locking you into another ecosystem. It's actually opening up the ecosystem and allowing you to utilize all of those tools and retain that experience and knowledge that you already have.
And having this software agnostic platform that allows you to push everyone to visualize and use the data together, you can see the changes each and every person is making, what they're doing. You can ask them questions, and then you can also push the data out to the vendors or the software platforms you need to do your specific tasks on, if they're inside Trimble or if they're outside Trimble. If you're having to do a load rating on a bridge or a site distance study, anything like that, you can use the most appropriate software that you know how to use, so you don't have to train up on a different one, and then bring that back into that common data environment, so that you're always investing in that digital as-built that you have been building.
And so continuing with our theme on the how, really touching on delving a little bit more into a little bit more detail about those APIs. What that means is they really do pave the way for better translation. So our Quadri technology lets you sit there, let's host that data and lets the APIs that we're looking at here create bidirectional connections to other software. So in other words, like we said, that could include Civil 3D, OpenRoads Designer, Revit, whatever is necessary. But for the nice thing about those APIs is, number one, they do enable you to, or essentially they enable you to share effectively more often. So you're not restricted to just a single 30, 60, 90 approach on a construction project, but you're able to be more innovative. You're able to do more sensitivity analyses, and this is tried and tested on other parts of the world where they've been utilizing this kind of approach, and the benefits are significant. We're talking about significant cost reductions, significant time reductions for construction, and then of course getting to that digital as-built. So part of that is where the data sits. And we've talked about it being an object-based model. So in other words, it's sitting on an Oracle spatial database, which means you have objects with properties. So what you're doing is you're breaking down the data into its core elements, and then you're adding an attribution to those core elements, which means then you can use that for querying, for subset selection, to be able to push out into other programs. It just gives you a lot more flexibility in that and a lot more confidence in the data, because what it means is then, not only tied in with the software agnostic approach, is that you're able to read in data in a particular format via those APIs, but then push it out in what other format may be a different format as a deliverable, and you're not losing data. So we're getting to a lossless approach here, or lossless translation of data via these, which is really truly enabled by these APIs and connections as such. And of course, that means then you can use the best tools for that application, and then be able to retain that existing knowledge and experience of your users that are a part of that process.
And this lossless translation of data is massive for determining why something occurred or how something occurred. So you can dive back into the history of it if for some reason there's a case that comes up of why is this bridge failed, why is this road settling the way it is, why are we seeing cracks and failures. We can dive into each of the records and really mine it for the history to understand and either improve our maintenance practices, provide information to our construction or our designers so that we can have better assets over time.
And so part of that how, again, is those APIs enable that bidirectional connection, right, to the native software, to Trimble's own software, and that could be Trimble Business Center, that could be Tekla Structures, whatever that may be. Again, creating that connection to the centralized data. So where that data sits is what we're calling our feature catalog, and that's really the object-oriented database. Really built on, at the moment, it's built on an ISO conforming standard. So what that means then is, not only are we dealing with a software agnostic approach, but it's a non-proprietary approach where the data is sitting. I've got a little note there about IFC, which we'll talk about in a second. But really how do those rules, or how do those APIs actually do that? So we call them conversion or presentation rules. Conversion rules really do provide a sophisticated way to read the data from the native format, to be able to query that, select it, query by specific word or by CAD standard or whatever. What that means then is regardless of the format, we're able to extract that data, bring it in and associate it with the items within the feature catalog. And because of those APIs being bidirectional, that means that we can also push changes back into the original design data. Of course, you can control that, but that functionality exists, which means that you're able to communicate more effectively and ensure that the designs that you get at the end of the process are truly representative of the project. And part of everything that we work with is really becomes part of that digital record. So all of the changes, all of the way that we bring data into the database, how we push things around, how we change attributes, all of those kinds of things are associated with that digital record. They're associated with tasks, which means traceability truly is woven into the process. So like what Max said, if there is an issue with a constructed project, we can delve back into the details and find out what's the geotechnical data done here, what's the pavement condition information, or whatever you may need to get access to. That's the beauty of having that information and that digital sort of history of the project as such.
And to echo Adrian, this API-centric approach is the way we can really share data and push data back and forth between all of the different platforms, with it being real-time, live, and allowing each agency and area to work independently, but see what the other area is doing at the same time. So construction can see, maintenance can see what construction and design are doing, and then construction and design could look into what maintenance is doing if they want. But it allows that data and that information to be seamlessly shared across the silos, breaking them down.
And so what are the complementing sort of, I would say, or I should say more parallel efforts that we are that are happening at the moment, of course, is the transition to IFC, or should I say adoption, resolution, whatever you want to call it. It's really the concept of utilizing IFC really boils down to the fact that it's a standardized form and essentially a schema for both buildings and infrastructure. And one of my colleagues in the industry has described, IFC as the PDF for the civil industry, and I think it's a very apt description, because what that means then again is you're able to share information. You can lock it down as you need to, but the main thing is that all of the attribution and information that we're dealing with is adhering to the international set standards, and that means not only naming conversion, naming of objects, but also the feature attribution on those really is all conforming to that standard. And so when we actually push that through, what does that actually look like? Or when we apply that, and again, this is the development that we're looking at the moment. This is where we believe we can really help push the industry along, is to get to a point where we may be looking at a road corridor, for instance, here, and all of the underlying data, all of the attributes on that right-hand side are not just a state-specific standardized code or CAD standard. These are IFC terms and IFC attributes, which means that you can bring in information. I can push it out. Again, ultimately, we kind of see the deliverable being an IFC, right? But maybe not. What if we wanted to push out a DGN or whatever? The nice thing is, if you've got that data sitting on that database and you've got everything adhering to that IFC schema and standards already and attribution, that means that's really aiding with this loss of minimization of loss between translation of data between a certain phase. That's really kind of going back to that original graphic where we were talking about trying to get to that accumulation of data. We certainly see IFC as a significant part of that, just because of the standardized terms and terminologies that are really a part of that 4.3 schema.
And having the IFC is the building codes of how you can share information. It's the SMBI. It's going to help you guys achieve the TAMP plans that you guys have in process. It just allows a more seamless data flow and ability to share, where having a formatted data and titles are the same. You can go between projects. You don't have that process of having to learn how your designers or your builders renamed your assets. You can just go ahead and everyone is on the same page from day one, which is really nice. And it means in the future, everyone can look back and see how assets are named, and they don't have to go try and look into a 1960 PDF and understand it. They already have the format and the rules around it, so now they can just go dig for the information they need to find.
And so what does that look like? As far as if we have the data stored in that object-based model, if we have the data on that data, it's sitting in that database, we're sharing and collaborating, we now want to push that out to the construction phase. So for starters, you can obviously have people see and collaborate and have as many eyes on the designs as you need to. And that's part of this whole minimizing that breakdown in data, is because if you've got more eyes on the designs, you're going to be able to identify issues far earlier on, far before they get to construction, which is when things get very expensive. If we need to go reconstruct things, if we need to have things done on site, it's a far greater expense than if we could do that back in the office prior to the construction phase. A simple example of utility relocation, being able to do that prior to construction saves a significant amount of time. But of course, you can only really do that if you've got access to that data and being able to share that between the contractor and the utility designer, to be able to ensure that those conflicts are minimized prior to construction. So we want to be able to push those designs out to the field. So we want to be able to push that technology out to, Trimble Business Center, or to products where we can actually create the constructible models. So these are the tools that are, the designs that are actually constructed, that are actually utilized and consumed by the machines to construct the project. They're actually going to use machine control. We're going to use grade control, infill systems, things that actually maximize the use of that data. So we're improving efficiency. And then, as talked about earlier on in the piece, these same machines are out there capturing data. They're capturing surfaces, they're capturing pass counts, compaction values. We're able to read that information back in from the site and then actually feed that into the process. So tools like Works Manager and WorksOS enable you to share that data back through the process and then push that back through Trimble Business Center into the actual, into that main database. So that's how you get to not only the cyclical approach here, but also ensure that you're not just pushing a design out to the field that gets constructed and who knows what changed from the original design. We're capturing that information as part of this process using these tools and technologies as such, and really what is truly facilitating the how of pushing that design throughout the whole process.
And what's fantastic is on the operation and maintenance side, by having all of this data being captured in the construction phase, means it's passed on to you all, which means if you're trying to locate a water main or sewer main or your utilities, you can visualize where in the model it is, and you can be more precise on where you need to go either dig or access, where you need to put up road controls and do safety management while you're out in the field. It allows you to just reduce your costs and have safer crews by having more data and being able to visualize it before you go out actually in the field with automobiles passing by you and all the different distractions of being in the field.
And so part of that, of course, is being able to capture data from the field. So this is really just delving into a little bit more detail that I was talking about, what does that actually, how does that actually translate into capturing data from the field? So what we're looking at here is where the project has been constructed. We have a dozer or a grader that's actually constructing the project according to that 3D design. It's actually capturing survey points as it's constructing the project. So it's generating a surface. So not only is that surface able to be utilized, or that data able to be utilized for progress mapping, so we can see exactly, how many times what's my pass count for my compaction area, or what's my cut fill, what's my target versus my actual, and really be able to really do what we call data-driven decision making. But really the benefit of capturing this data, which is, may or may not have in the past have been utilized, is where we're adding to that accumulation of data. So on the right-hand side, we're looking at a graphic of where each of those little points there, it's a mesh, but it also has values on each of those. So that may be a pass count. Again, that could be a compaction value, whatever it is. There's intelligence that's being captured as part of that process. And at any time, we can actually feed that information back into the process. We can create a surface from it. We can do comparative analyses. This is really how we get to what we're calling the intelligent digital as-built, because that then becomes part of the history of the project. So if you get further down the track and I'm sure, Max has already touched on some of this as well. If you get further down the track and there's an area of subsidence in a road, we can go back and look at the original core data. Perhaps it was over compacted, perhaps it was under compacted, and be able to do some of that traceability that we're talking about. That's the value of having access to that information versus having to just figure it out later on, or not even be able to have access to that information as part of the operations and maintenance phase.
Yeah, Adrian, you stole my thunder on that one. Having that soil compaction value, any of that information, if your assets deteriorate over time, you can go back into history and start asking those why questions. Why are we seeing rutting? Why are we seeing faulting? Is it because we didn't compact properly? Do we not have the correct moisture values? Too many passes, too little passes? All of that can be, refined and dug out of the data and looked into, so that you can help refine your construction methods and what you send out in your bids. And then you can also compare your present day values to what you had in the design and see how they've altered and changed over time, and do load ratings on bridges or any type of assessments that you need that might have changed just due to the asset deteriorating in its normal state.
And so part of what we're talking about here is really, yes, we want to get to that digital as-built, but what we want to talk about is what are the tools and technologies that help you get there. So we're touching on the workflows, and here's some of what we want to highlight here too is some of the technology that's providing the raw data. So in other words, things such as being able to capture LiDAR surfaces from photogrammetric interpretation from from drone data, and being able to combine that with terrestrial data as well. So then you kind of get the best of both worlds. The nice thing, of course, then is you can use that as creating a bit of a timeline for a project, and we'll talk about that in a second. But really what that means then is we've got all of those machines out there capturing data there, and it's combining with all these tools that we're highlighting here to capture that raw data. So photogrammetric data, being able to capture imagery, and then be able to feed that into statistical analysis to be able to look at, am I meeting my targets? Being able to do those comparative analyses as such. You can't really do any of that sort of data analysis or interpretation without having these raw tools and these both hardware and software that Trimble's providing to really help capture that data in the field, essentially both pre and post construction as well.
And then in the operation and maintenance phase, you will eventually see these tools trickling down into those, so you can capture data through imagery as well as LiDAR, so that you can better assess your assets, track them, and then continue doing this statistical modeling across time, so you can see how your assets are maintaining.
And so part of the approach, of course, is being able to visualize that data. So one of the things we like to highlight is the utilization and what I would call democratization of data as well, because what that means is we can have that data stored within the Quadri database. We can have sharing and collaboration built around it, but then we can start to use tools such as Sight Vision, where we can visualize extremely complex data in the field. But you don't have to be a construction expert to be able to review that information, or a surveyor or inspector. The value of having access to that information via a connected device with highly accurate positioning, thanks to tools like Sight Vision, where we can get down to 2 to 3 centimeter accuracy. What that means is you're seeing the data in its true location, which means you can also do observations and being able to really feed that observation, that inspection component back into the process, identify those issues prior to maybe final construction or part of the inspection process. So the nice thing about that is any of those tools and technologies that we're looking at here are creating that digital data. Tools such as Sight Vision help you visualize that in the field, and then that same data is what becomes that digital as-built. So attribution and being able to add metadata is then what feeds into the operations and maintenance side of things, as long as being able to visualize it throughout the entire process with tools such as Sight Vision.
And with tools such as Sight Vision, when you're going to visualize your maintenance assets and you're reactively having to respond to some type of sewer or needing to go in and repair a utility line that's underneath the pavement, underneath your sidewalk, or on the median or side of the road, you know where to go. You can go locate that quickly through the visual model. You'll be able to visualize what it looks like in the field, and then when you drive out into the field, you know exactly where to go to, where to dig, how much to dig to access that. So you're reducing your costs, and you're able to be just more efficient and respond quicker to any type of reactive scenarios.
And so part of that process is really, if we want to create those designs, create that digital as-built and feed it into the process, is really, we want to highlight the fact that we can simplify your workflows by having that as-built as part of the entire operations and maintenance phase, which, again, historically, you may not have had that. You're able to optimize based on those tools and then boost efficiency by utilizing that data as part of the process. And that really does feed into the significant part of the rest of the asset life, because you've got that information that we've just been talking about, capturing all of that and then feeding it into the operations and maintenance side.
And on the operation and maintenance side, we're maintaining these assets for 25, 50 years. So we have a much longer duration where we need the data. We need all of that information that was coming from the design and construction so that we can do our best to maintain these assets for the longevity and try and push the assets life cycle for even longer if needed.
And so what we wanted to highlight here for the remainder of the presentation really is just some examples or some case studies where we're actually applying this technology and really utilizing all of the tools that we were just touching on. Now, there's certainly more to it, but what we wanted to do was highlight some of those key technologies, and really that's what we're looking at here. So if we're looking at a capture like here where the data is reflective of the model that's stored within the Quadri database, we've got alignment and construction information. You've got asset utility information built into that as well. And so what is that, what is that actually comprising? So not only can we start to use that information for visualization like we were looking at where we had that digital data, really combined into one place. What we're ending up with, in this particular case with Caltrans and the SR99 project, it's a bridge replacement study. They literally applied a number of these technologies. It was a collaborative effort between Granite and Caltrans, where the bridges were designed in Tekla structures, the road corridors were designed with Civil 3D. The point cloud data was captured from Stratus, so we've got drones flying over, capturing point clouds, ortho imagery as well, being able to drape that on those surfaces, being able to bring metadata and associate that with the objects within the database itself. And that also includes some GIS information, so asset utility information. All of that has been combined into a single example here where we had all of that information as part of the construction phase, which is now basically rolling over into the asset phase. But there's certainly more information that we can add to this, and that's the beauty of this process is it becomes this sort of living, breathing representation of the project because it's including all of this data that we started off with. But now we can append to this. We can actually update the designs if there's a change, if something needs to be reconstructed as part of the process. All of that information is then fed into that design and as-built model as well.
And you can see we're not just capturing the road surfaces and the actual built objects, we're capturing everything around that. So if you're having to generate a vegetation management plan or try and predict what vegetation needs to be reduced, where you need to do mowing and remove limbs from trees, so they remove it all from your road surfaces, you can have drones fly over, on a yearly, bi-yearly basis, and you can start identifying that and watching it over time. You can identify areas that maybe you need to cut back, maybe areas that you don't need to do as much work on, and you'll be able to build that time history over and over again and send your crews out more efficiently to areas that you need to go to.
And so what does that actually look like? So, Max was talking about the temporal part, and what that means is we can be having drones or of course even terrestrial data capture either weekly, bi-weekly, whatever you like. The nice thing is then you start to build up a timeline. So that can actually be used throughout the process or the construction phase, because we can be easily looking at my design versus my actuals and be able to make data-driven decision-making saying, well, this is our design, this is our actual, our schedule is either a little bit behind, we're not going to make it, we need to bring more equipment on site or more survey crews or more construction crews, I should say, to be able to meet that target. So that's the value of having access to that information. And by having this temporal nature here, we can always go back and look at the timeline and see what was done throughout the whole process. And that feeds into this whole historical component of the digital as-built, because this information will always be there. It can always be a part of it and always help for investigative aspects if there are some issues with the operations and maintenance side.
Yeah, and temporal data on the investigative side is really the best data to be able to go look at to see what the road conditions were in prior to an accident or after an accident, because you're always trying to discover and look for understandings of why something is occurring. So being able to go through a temporal data to assess what's going on is critical, and it's fantastic to have that amount of data to see.
And so what does that end up looking like as we expand that capability? So what we're looking at here is utilization of the APIs that where we're connecting Civil 3D and the object-based database within Quadri. And what that means is we're able to better utilize the existing source data attribution. So with this particular case here, we're looking at a Caltrans data set where they were able to, or where we were able to, via those APIs, to extract and read the ASHTO-aware pay item codes, and associate those with the elements within the feature catalog or where the data sits. And the best part about that is that becomes effectively a number of attributes on that object, which may or may not have been captured in the past or kept in the past. So that's how we get to this accumulation of data. So what that also means then is we can now query by those objects or those pay item codes, or we can actually isolate them. But then we can also use those as part of what we call our presentation rules, which is where we can associate standardized colors, textures, and be able to represent those in many different fashions, or as they were originally intended in the original program. That's the value of being able to retain that information and have it as part of the process as such. So the value of capturing that data, extracting it, and then again, it's always incorporated with the individual elements within the feature catalog there.
And being able to visualize the different elements that go into the building of a structure, the building of the roadway, any of that allows you to be more precise in the maintenance and the rework or the items that you need to go tackle from the operation and the maintenance side, because you know where that is specifically located. You know how deep it is, how wide it is, how much material you're actually needing to go out and use. So you can see how much material your crew might have put down on the maintenance versus what actually that the material quantity initially was used for during construction.
And then last little couple of slides here, really to talk about some other examples. So here we're working with Florida DOT on their SR 415 job, where as you can see from this particular project, it hasn't even begun construction. So the nice thing is we're already in the pre-construction phase. So we're utilizing the designs, we're analyzing them for errors. We're able to take those digital designs out to the field, and that's exactly what we did here. We're able to take it out with tools such as Sight Vision, but also to many of our other geospatial tools. We can take out the robots out there and be able to, do stakeout on those designs and compare, and the actuals versus the design, feed that into the process. And here we're looking at a Sight Vision visualization of a centralized alignment with all of the surface information. This was a resurfacing job. This is about to go to letting. So it's a nice little way of showing that we can actually have quadri throughout the entire process. And the nice thing is all of that information, all of these visual inspections, although that data has been captured, that's part of the process prior to even getting to construction. So once it does go to construction, then we can use that information and intelligence, add it into the as-built, and feed it into the process as such. So we also like to show, what's some of the examples of where, in a mature BIM environment where we've got, these tools and technologies that have been applied for many years. And as we know, the Scandinavian countries, or in this particular case, Norway, for instance, they've been applying this technology. They mandate the use of the of quadri, or this type of technology on any large infrastructure project. And so these are the benefits that we can see. Obviously, we're a little bit behind this, but we're putting in some of these tools and steps in place to get to this. And that's really where a simple example of one of the most recent projects here, where it was the country's shortest construction time in a road project, 20% below the original project cost. Change orders and additions were less than 2%. And you can imagine that's just simply because there was communication and collaboration between the designer and the contractor. So you're optimizing that design, making sure that it's constructible, and be able to minimize all of that rework. And so what that also ultimately results in is very low level conflicts between the owner and the contractor, because they've been communicating so much throughout the whole process, which really results in a win-win for both the owner, the designer, and the contractor as well, to ensure that you get to this sort of project. But again, we just like to highlight that this is what's happening in the mature BIM environment, where they've been applying all these tools, and really the realization of these benefits and aspects are currently in play.
And with all of these, this connected workflow, this ability to reduce change orders, to reduce project cost, we're creating more sustainable projects and doing it in a more sustainable manner across time. So our emissions are lower and we're doing more with less.
And thanks for that, Max. And so in that case, then we've covered our content. So I will hand it back to you, Nick, for your subtle guidance there.
Yeah, great job, guys. There's definitely plenty of questions in the panel, but one quick final poll to launch based off of today's presentation. How do y'all feel 3D visualization of your assets? Would that be beneficial for your organization based on what Adrian and Max talked about? And while you guys are doing that, Max, Adrian, I'm just going to throw questions out. Whoever wants to jump in and take them, go for it. With rapid technological advances and some fierce competition in planning, design, and construction, what are some of the driving factors as a significant shift in a way infrastructure projects are developed and implemented in the construction sector?
I can go first, maybe if you want to jump in after that, Max. I mean, so
Yeah.
I would say, one of the significant drivers really is the setting of specifications and deliverables, because until the owner and designers have specifications or deliverables to provide a model that is, either something that is along the lines of, say, like utilizing a CMGC contract mechanism where they must collaborate, or again, ultimately it comes down to the deliverables, say, providing that digital data in the first place, and then being able to ensure communication and collaboration between the contractor to make sure that those designs are closer to constructible, so that you're minimizing rework there. And so I would say, there's many other aspects, but until that kind of happens, I mean, the industry is going to take its time. There's certainly those that are innovators out there, of course, but having that deliverable there is going to have a significant impact, both upstream and downstream with the construction phase.
Yeah, and I'd echo Adrian on that completely, in the fact that by having a requirement for having a digital as built in the design and construction phase, that'll pass seamlessly into the maintenance phase. It'll take a second for everybody to get on board to utilize and see how useful a 3D visualization of their assets are over time in the maintenance phase, but you need to start out during construction and design and having those models so that you can not have to recreate them in the maintenance side.
Awesome. So we have a lot of questions and not a lot of time. So if we don't get to your question, I apologize. Please email us after. So here's a quick result of the poll. About 70% do believe that the 3D visualization would be a benefit for assets. Next question, again, we'll kind of try to roll through these. Does Quadri allow you to create a schedule or table for features within the digital twin? So if I wanted to do a listing of all the catch basins within a model and list it out by type in a summary format.
So yes, it can. So, but it ultimately comes down to the source data. So if you're able to ensure that that is either an attribute or it's something that you can query within the source data, then once it's brought into Quadri and then it can be associated with a feature attribute, then that's where you can then query by that information. We can do tabular outputs. I could query, for instance, if I've got all of my objects in the representative of my pavement, I could query that and actually get a rough estimate of the quantity of pavement, for instance. So that's a simple example, but again, as long as it's in the source data, then the APIs are set up to extract that from that and then associated with the data within the Quadri database, then yes.
How does one incorporate current data into the IFC standard and schema?
So current data, I mean, I guess it depends. So like, as far as, I mean, IFC really is the standardized terms and terminologies and attribution, right? So once the catch at the moment, of course, is yes, the IFC schema is technically, I believe it's pretty close to being locked down, or should I say it's locked down, but it's in the final approval process. Once that's done, then that schema, and I mean, there's a draft that's available right now. So one of the things that you could do is to actually take that draft and actually, which is essentially what we're looking at now for our database too, is to ensure that effectively all of the terminology, attribution are all meeting those, and essentially then when you export that information as an IFC, then they are essentially that's a one-to-one translation with those terms. So that's kind of the preemptive work I think you could do. I mean, like I said, because it's in draft form, it's obviously not finalized, but I believe it should be finalized quite soon. And once that is, then you could be ensure that those terms and terminologies will not change. But that would be the step that I would recommend.
In y'all's experience, how willing are design build companies willing to implement the IFC standards?
So lots of interest in IFC. That's good. I mean, I would say those that are innovative are looking at it. For instance, we have worked on a number of projects where there's been or I would say example or maybe sample IFC files in there where they've tried to utilize either the previous schema or maybe utilizing the new one with in beta terms. But I mean, I think that would be the best sort of way to do that, is to see what the capability is in its current form. Again, because it's still in a little bit of flux, that would probably be the biggest issue there. But I mean, as far as maybe exporting that data, maybe having it, as long as you're, if you're providing a data deliverable or even a data design and providing it in as a DGN and then also maybe as an IFC as well. And whereas obviously still the main DGN or DWG is the primary design, just to have it alongside it. I would say that would probably be the best way to start that approach. And we are certainly seeing interest in that because of the value and because that's where the industry is going.
Max, Adrian, we do have to wrap up. Do y'all have any final things to add before we close out for the day?
From my standpoint, Max or I are resources, and I'll let Max jump in. But for me, we're happy to be a resource. If you've got any questions, if you wanted to delve into any of these aspects, there's a lot of information we covered today, but we could delve into those in any more detail and look at a demonstration or whatever of these tools at a later date as well.
Yeah, feel free to reach out. We're happy to answer questions and see the different examples you guys are wanting to incorporate and how you guys are thinking of incorporating them now.
Awesome. Well, thank you, Adrian and Max. Thanks for everyone for joining us. I know we didn't get to some of the questions, but we are bumping up on time. So if you didn't have one of your questions answered, please throw us info@agileassets.com. We'll throw it out there if you have any additional questions that we did not get to. The video and slides will be available in the next 3 to 5 days. I know that was one of the questions in the chat. We will send out the presentation, the slides, everything. Please stick around also after for the conclusion of the webinar. We do have a post survey. And again, if you have any other questions, don't don't hesitate to reach out. We do have another webinar coming up on March 23rd, and that one's going to surround securing infrastructure funds for grants, securing grant funds for infrastructure. If you're interested in that, we will have an email about that coming out very, very soon. Thanks again for joining us, everybody. Have a great rest of your day.